You ran a little test last week. Version B of your checkout page converted at 60%, version A at 40%, and you are already halfway through rebuilding the whole site around the winner. Then you look at the raw numbers underneath those percentages, and version B won because 3 people bought instead of 2. That is not a result. That is a coin landing heads a couple of extra times. Today I want to talk about sample size, the quiet question of how much data you actually need before a number means anything. Because getting this wrong is how a solo business ends up chasing pure luck. I am not a statistician. I am someone who runs small businesses and has been fooled by a thin number more times than I would like to admit. I have rebuilt a landing page on a difference that turned out to be noise, and I have killed a perfectly good idea because a handful of early customers happened to go quiet that week. So this is not a lecture on formulas. It is the habit I now use to ask whether a number is real or just small, and none of it needs anything beyond counting the events you already have. What sample size actually is? Sample size is simply the number of observations sitting behind a number. Not the traffic to your site, not the followers on the list, but the count of the specific thing you are measuring. If you care about your conversion rate, the sample is the number of people who actually reach the decision, and the events are the ones who bought. A percentage always hides two numbers. How many did the thing and how many could have? And the sample size is that second number. The smaller it is, the less the percentage sitting on top of it deserves your trust. Why a small sample lies? A small sample lies because it is mostly luck. When only a few events sit behind a number, each single one yanks the percentage around hard. 2 sales out of 10 is 20%, but one more sale is 30%, so a single customer just moved your rate 10 whole points. Nothing about the business changed. One more person simply happened to say yes that afternoon. The fewer events you have, the more each random one dominates. And the number built on a handful of them is telling you far more about chance than about your customers. The coin flip you already understand. You already have the right instinct for this from coins. Flip a fair coin 4 times and getting 3 heads is completely ordinary. It happens all the time and you would never call the coin rigged on that evidence. Flip it 400 times and landing on 300 heads would be extraordinary. The coin has not changed, only the amount of evidence has. Your conversion rates, your reply rates, your open rates all behave exactly the same way. A lopsided result from a tiny test is the 4 flip coin, and you should meet it with the same shrug. Signal versus noise. Every number you measure is really 2 things added together, the true underlying rate and a layer of random wobble on top. The true rate is the signal, the thing you actually want to know. The wobble is noise, the luck of who happened to show up this week. A big sample averages that noise down until the signal shows through clearly. A small sample is almost all noise, a thin skin of luck with barely any signal underneath, and the cruel part is that noise looks exactly like signal until you stop and check how much data made it. The wobble shrinks slowly. Here is the part that makes small businesses ache. The wobble does not shrink in step with your effort, it shrinks with the square root of the sample. In plain English, that means to cut your uncertainty in half, you need 4 times the data, not twice as much. To cut it to a third, you need 9 times as much. The returns diminish fast, so the jump from 10 events to 100 buys you an enormous amount, while the jump from 1,000 to 2,000 buys you almost nothing. That is precisely why real certainty is so expensive. What actually decides how much you need? 3 things set how much data a question needs. First, the size of the difference you are trying to detect, because a big obvious gap shows up in a small sample, while a tiny one hides in a huge one. Second, how rare the event is, because a 1% conversion rate needs far more visitors to pile up enough actual sales. Third, how sure you want to be before you act on it. You cannot escape these 3, but once you can feel them, you can tell in advance whether your little business is ever going to answer the question you are asking. Small differences need enormous samples. This is the trap that catches founders most often. Detecting whether a change lifted your rate by 30% might take only a few hundred events. Detecting a 1% lift, the kind a new button color usually delivers, can take tens of thousands. A solo business almost never has the traffic for the second one, which sounds like bad news, but is actually freeing. It means you should stop running thin tests on trivial tweaks and spend your limited data on the big, bold changes that a small sample can genuinely detect. Count the events, not the visits. When you judge whether a test is big enough, count the events, never the visits. A page with 50,000 visitors sounds enormous, but if it converts at 0.5%, that is only 250 sales split across 2 versions, which is thin. It is always the rare thing, the conversion, the reply, the upgrade that runs out first, and it is the one that decides your sample size. A giant traffic number wrapped around a tiny pile of actual events is one of the most common ways a test quietly fools a busy operator. Do not peak and stop early. One of the surest ways to fool yourself is to watch a test live and stop it the moment your favorite version pulls ahead. Because the numbers wobble constantly. One side is always temporarily winning, and if you quit the instant that happens, you have simply waited for a random high and called it a result. The fix is boring, but it works. Decide roughly how many events you need before you start. Let the test reach that size, and only then look. Deciding the finish line after seeing the race is how noise gets promoted to fact. Beware the tiny slice. The same trap hides inside your dashboards whenever you slice the data. You look at conversion for one small country, or one pricing plan, or last Tuesday, and the dramatic number leaps out before you act on it. Look at how many events built it. A slice narrow enough to be interesting is often narrow enough to be almost empty. And the striking pattern is just 3 or 4 people being 3 or 4 people. The more finely you cut the data, the smaller each sample gets, and the more of what you see is noise wearing the costume of insight. No difference is not the same as no data. A small test can mislead you in the other direction too. If your little experiment shows no clear winner, that does not prove the 2 versions are equal. It may simply be too small to see a real difference that is genuinely there. Statisticians call that being underpowered, and in plain terms it means absence of evidence is not evidence of absence. A thin test that comes back flat is not telling you the change did nothing. It is telling you that you never gathered enough data to find out either way. The honest answer for a business of 1. So here is the honest answer most articles will not give you. A lot of solo businesses will never have enough traffic to run proper statistical tests on small changes, and no clever trick fixes that. Rather than fake it, change what you test. Make bigger, braver changes whose effects are large enough to show up in the data you do have. And for the small stuff, accept that you are deciding on taste and judgment, not on a real result, which is perfectly fine as long as you are honest with yourself that that is what you are doing. What to do when you are small? When the data is too thin to trust, you still have good options. Pool a longer period and judge a change over months instead of a single jumpy week. Watch the direction of a number over time rather than obsessing over one comparison. Lean on bigger, more obvious bets where you do not need a microscope to see the effect. And talk to your actual customers, because 5 honest conversations often teach a small operator more than a test that was never going to reach a size worth believing in the first place. The one check before you believe a percentage. If you remember nothing else, remember this one move. Before you trust any percentage, look at the raw counts underneath it and ask how many. 60% against 40% sounds decisive until you see it was 3 against 2. Once you are in the habit of reading the events beneath the rate, most of the fake results in your own dashboard simply dissolve, and you stop spending real effort chasing numbers that were only ever the size of a rounding error. Every one of these explainers lives in writing at dataresearchanalysiscollection.com. The whole metric library in plain English, with sample size worked through on a real thin test rather than a tidy textbook one. I keep it honest there for the same reason I keep it honest here. No promises about your results, and no pretending a small test can carry a big decision. Read it slowly with your own numbers open, and you will start seeing which of your recent wins were real and which were just a few lucky events landing in a row. The honest limit, and hold the whole idea in proportion. Sample size will not grow your business, and it cannot hand you certainty, because nothing can. All it does is tell you when to trust a number and when to shrug at it. Which of your results earned a decision and which were only noise dressed up as news. That judgment, knowing the difference between a real signal and a small pile of luck, quietly saves you from more wasted rebuilds and abandoned good ideas than any tool you could ever buy. So to recap, sample size is the count of events behind a number, and the fewer there are, the more that number is luck rather than truth. Treat a lopsided result from a tiny test like 3 heads from 4 coin flips, Remember, the wobble only shrinks with the square root of the data, and count the events rather than the visits. Decide your finish line before you look, distrust dramatic numbers from tiny slices, and never read a flat small test as proof of no difference when you are too small to test properly. Make bigger bets and talk to real people instead. Next time, I want to talk about confidence intervals, the honest way to show a number as a range instead of a single false point. I will see you in the next one.